All right, so we've learned about the inner planets. Now let's learn a little bit about the outer planets. So the objectives of this one are going to be to summarize the characteristics of the outer planets, describe their physical properties, locations, and movements, and to compare and contrast the outer and inner planets. So, characteristics of outer planets. They generally are fast rotating, slow revolution. So that means since they have a long distance away from the sun, it takes them a longer time to go around the sun than the inner planets. But they have faster rotations around their axes. So that means they have like shorter days compared to Earth and the inner planets. They're very large comparatively. So compared to the inner planets, they're very large. They have many moons, very low density. They're gaseous planets most of the time, and they have rings. So, as we know, they're separated by the asteroid belt between Jupiter and Mars. We talked about that in the last lecture. And then continuing on from Mercury, Venus, Earth, Mars, we go Jupiter, Saturn, Uranus, Neptune. So you can create your own mnemonic for that. Yeah, just create your own mnemonic. I'm not going to do it right now. So remember, the inner planets are small, rocky slash terrestrial. They're very dense, and they have few moons and no rings. Earth has one moon, and Mars has two moons. So Jupiter. Jupiter is the fifth planet from the Sun after Mars. It's the largest, most massive planet by far. It weighs more than all of the other planets combined times two, and it's 10 times larger than the Earth's diameter. So if you remember, Earth is the largest inner planet. Multiply that by 10, and you get Jupiter. So its atmosphere is mainly hydrogen and helium, but it also has a little bit of water vapor. It's got 50 moons. Those are known moons. We have like 9 provisional moons or something like that. So it's going to have more moons being added onto it in the next upcoming years. We just haven't really found them yet. We know that they're kind of there, but we need to have some sort of probe or telescope find them and actually see that they're orbiting around Jupiter. So Jupiter has 3 rings. And a ring is just a wide, flat disk containing ice and rock particles orbiting around a planet. So it's mostly just like gaseous ice and rock particles, and it just kind of goes around the planet. So it creates this little ring effect, but it's mostly just gases. Its revolution is 11.86 Earth years. So every time the Earth spins around the sun, that's 1 year, 1 Earth year. So this revolution around the sun for Jupiter takes 11.86 of those. Its rotation, though, is only 0.41 Earth days. So it's spinning very quickly around its axis. And if you can imagine, it's 10 times larger than Earth, and it's spinning around almost a little more than twice as fast as Earth does. So it's going to generate really fast winds and storms on that planet, especially since it's gaseous. So it has a great red spot. And the Great Red Spot is just this really, really large storm that's been going on for around 100 years. It could have been going on for a little longer. We're not 100% sure because people haven't been looking at Jupiter very closely for a very long time. And the Great Red Spot, this storm on Jupiter, is about 2 times as wide as Earth. So just a little teeny part of Jupiter, which is a storm, is 2 times as wide as the whole planet Earth. So Jupiter is humongous. And the center of the planet is actually going to be a lot of liquid hydrogen, and then it has a rocky core. So it's got to have something to kind of hold it together, and that's going to be that dense rocky core. And then like our mantle would be kind of comparable to its liquid hydrogen center. So here's a comparison of Jupiter to Earth. So, and then here's that Great Red Spot, that storm. It kind of shifts. Sometimes it's over here. Sometimes it moves over here. It takes about 10 years or so, maybe a little longer for that thing to shift because it's so humongous. Let's get into Saturn. This is exactly what Saturn looks like with all the cats on it too. So, don't question that. The Saturn is the 6th planet from the Sun. It's the 2nd largest, but it's the least dense. So it's mainly gas. It's less dense than water. So if you had a glass of water that was big enough to put Saturn in it, it would float on top of that glass of water. It's the 2nd largest planet, but it has less than 1/3 the mass of Jupiter. So that just tells you how huge Jupiter is, really. Saturn is enormous, but it's 1/3 of Jupiter's size. Saturn has 53 moons. It has around 10 provisional moons, so we're still trying to figure out if it's got more moons in there or not. It's got the largest and most visible rings by far. The rings, I'm pretty sure, something like 3 times as wide as Earth or something like that. Oh no, 4 times the diameter of Earth is the ring, their rings here. That's what it is. The revolution of Saturn takes 29.45 Earth years. So that's, we're getting farther away from the sun, so it's taking a longer time to go around the sun. You'll see this number increase drastically with our upcoming planets. And its rotation is about 0.44 Earth days. So it spins around almost twice as fast as Earth does for a day. So you're going to see the gases on that planet are going to be very reactionary and move around a lot, like kind of like Jupiter with those storms. You're going to see a lot of that too in Saturn. So here's just a really good picture of Saturn. Here's some moons outside of it. It's got 53 of them. And then Uranus, or Uranus, however you want to pronounce it. It's funnier the other way, so say it however you want. I don't care. It's the 7th planet from the sun. It's known as one of 2 ice giants in the solar system. So the next one is going to be Neptune. Obviously, it's the last one. It's blue, and that blue color is due to a lot of methane in the atmosphere. And methane is CH4. We should all know that. We have a lot of it in our atmosphere. Uranus has 27 moons. It's got rings. It's got about 13 narrow rings. They're hard to see a lot of the time. Its revolution is 84 Earth years. So, that's telling you it's extremely far from the sun. So I believe that Uranus is twice as far from the sun as Saturn is. So if you can imagine, Saturn's really far away from the sun. Now you multiply that distance by 2, and that's where Uranus is. So it's extremely far away from the sun. 84 Earth years is Uranus's revolution. 29 Earth years is Saturn's. So that just shows you how far away we've gotten. Its rotation is about 0.72 Earth days, which is really close. It's about 17.24 hours per day, and it's got a tilted axis. So the cool thing about Uranus's tilted axis is that it rotates from top to bottom. So it rotates like this, rather than most other planets rotate like this. So scientists believe that a collision may have made that happen. So a collision big enough to make a whole planet go from this to this. Imagine that. It would have had to have been something spectacular to watch. And then here's Uranus. You see these rings. This shows you that it's spinning this way, because most rings go around horizontally like this. So this is just, the orbit. All that dust and ice particles orbiting around it this way because of the tilt. It also has intense storms. These are way more intense than Jupiter. Okay, so check this out. We've got this great dot here. That's going to be a big storm. And then this one is like another time-lapse picture. No storms. Then this was a time-lapse picture shortly afterwards. We've got all these storms here. So, it varies greatly, the storms in the atmosphere. You get 1, and then you go from 1 to like 10, and these are all huge. And then you got a couple little ones here. So Uranus is highly volatile in terms of storms. Neptune. This is going to be our last planet. So they took Pluto away. They turned it into a dwarf planet. We'll talk about dwarf planets later. So Neptune is our 8th planet. It's our last planet. It's the 8th one from the sun. It's got a blue color as well, and that's because of methane, or CH4, in the atmosphere. And it's the other ice giant in the solar system. So both of these are extremely icy, Neptune and Uranus. It's got 13 moons, and it's got some provisionary ones as well. So we'll still figure that out in upcoming years. It's just really hard to get so far out there. These things are so far away. They're light years away, or maybe not quite light years, but they're really far away. Neptune's revolution is about 164.7 Earth years. So, you guys are all going to be dead by the time this thing goes around the sun. We all are. This is like 3 generations worth of people. So a lot of people don't get to see a full revolution of Neptune. They have to watch it in a time lapse from previous years. Its rotation is about 0.67 Earth days. So that's relatively close. That's around, I think it's 16 hours. Yeah, it's about 16 hours. It's got 9 rings. These are, you know, we can't really see them all that well because it's so far away, but we know there are about 9 rings. Its atmosphere is active and changing. Dark storms like Jupiter come and go. Yeah, they come and go though, so it's a little different like than Jupiter. It's kind of like Uranus, how Uranus had these storms. You know, here's a storm, it's gone. Here's a storm, it's gone. They just come and go pretty quickly, unlike Jupiter, which has a 100-plus-year-old storm. And then here, you can see the storm right here. There's storms. This is just it's spinning and creating this storm on its atmosphere, in its atmosphere. So this may change within 5 to 10 years. You may see it up here. You may just see it disappear. You know, you're going to see storms popping up everywhere. And then here's Neptune in comparison to the Earth. It's a lot bigger. And then here's just another picture of Neptune with its rings. So you can kind of see here how it's got rings. And there's probably some asteroids right in here where there aren't rings. And that's going to be the end of the outer planets. So if you have any questions, comments, or concerns, go ahead, let me know. Text, call, Schoology, all sorts of ways you can get a hold of me. Otherwise, have a wonderful week.